All right. So greetings, YouTube. Greetings, scholars. We're continuing with our next installment for chapter 2, set theory for College Algebra 1. Okay. And we're going to be working on section 2.4, set operations and Venn diagrams. So some objectives here. It's a fairly short section. We like to perform set operations with 3 sets, use Venn diagrams with 3 sets, and use Venn diagrams to prove equality of sets. Okay, so given these, 4 sets, find A intersection B union C prime. Okay. Okay, so I'm tempted to do a Venn diagram, but I think this might be a little bit easier if we just take it part by part. So, you know, the order, we want to do the things within the parentheses first, right? And so within the parentheses, we have that B union C prime. We want to do the C prime first, right? Let me think if that's how they. I just want to glance at something really quickly. Yeah, I think we're okay. Okay. So then C prime. So that's going to be everything that's in U but not in C. U are going to be the counting numbers from 1 to 9. So then C prime is going to be what? The set 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, that's C prime. So next, let's go ahead and find B union C prime. Okay. So in other words, what we want to do is combine the set B with these sets. So we want to put these elements together with no repeats. Okay. So it looks like we have 1, 2, 3. There's no 4, but there's a 5, 6. There's no 7, but there's an 8 and a 9. So I just combine those 2 sets together. Okay. Lastly, we want to say A intersection this set, right? So then A intersection B union C prime. So we want to take the set A and intersect. So what does it have in common with the set we just generated? It looks like they both have a 1, 2, 3, and 5. 1, 2, 3, and 5. Okay. It's going to be the set 1, 2, 3, and 5. Okay. And we see the final set here. All right, and I think they essentially did the same thing that we did. Okay. So Venn diagrams with 3 sets. The region shown in dark blue, this region represents the elements that are common to sets A, B, and C. So that's A intersection B intersection C. And that's this region 5. It kind of looks like a shield. Region 5 is this region here. So that's the intersection of all 3 sets. The region shown in light blue, that's going to be regions 2, 4, and 6. All right, light blue represents the elements that are in sets A and B that are not in set C. All right, so that's this region 2 here, a different kind of shield. Almost, I think that reminds me of like Star Trek, a Star Trek symbol, some kind of space symbol. Anyway, all right. I feel like this is okay. I'm going to kind of let this be for now. I feel like this would be better explained with an example. So you use the Venn diagram to find these different sets, okay? So for instance, set A, so if we look at the circle A, we want all the elements that are in circle A. Basically, we're talking about regions 1, 2, 4, and 5. So if we put those together, regions, I'll just do it by regions for the sake of space. So we said regions 1, 2, 4, and 5. A union B, so we want to combine A with B and don't do the repeat. So like don't list anything more than once. So we're talking about regions 1, 2, 3, 4, 5, and 6. So I'm just going to abbreviate it as regions 1 through 6. Okay. B intersection C, so those regions that are common to both B and C, that's regions 5 and 6. C complement, everything that's in U but outside of C. So that's regions 1, 2, 3, and 8. A intersection B intersection C is just region 5. So I just did this based on regions, and you can basically fill in the elements of each of those regions. Okay, and let me see. 1, 2, 4, and 5, 1 through 6, 5 and 6, 1, 2, 3, 8, and 5. Okay, so I think we got this. Okay. Party's almost over. What a bummer. So prove that A intersection B complement is A complement union B complement. Okay, so A intersection B is going to be region, I guess you could say region 2. So then the complement of that set is going to be everything in U, not in 2. Okay. Yeah, that's fine, I guess. So then A intersection B complement is going to be everything except region 2. So 1, 3, 4. I don't know if those are regions or elements. We'll just say it's our regions 1, 3, and 4. Right. So then A complement union B complement. So let's highlight this guy. So let's go ahead and find A complement. That's everything that's in U that's not in A. That's going to be regions 3 and 4. Okay. And then B complement, everything in U, not in B, are going to be regions 1 and 4. Okay. So then A complement union B complement, we're going to combine those two sets together, or all these regions together. Okay. 1, 3, 4, right? And notice that these two are indeed the same. That's the time. Okay, we're doing good on time. Oh. Right. Mm-hmm. All right, so I think they did the same thing that we did essentially. Okay. So the Morgan's laws. A intersection B complement, like we just saw, basically when you apply the Morgan's law, the opposite or the complement of the intersection becomes a union, right? It's almost like we distribute this prime, right? So then it becomes A prime union B prime. Also, A union B complement is going to be A complement intersection B complement. So it's like everything flips on the inside. So the complement of the intersection is the union of complements. The complement of the union is going to be the intersection of the complements. Okay. Oh, that was it. Okay. Well, we still got a good amount of time, so I will go ahead. We'll load the next section momentarily. All right. And on that note, we're going to end the session here. And from one beautiful mind to another, Enjoy your day. I'll see you all later today. Take care. Peace.